keyed into how you set up your research trial and where to pick your location and stuff. Now you're ready to go to the field and start establishing your trial. So your first thing is your seeding operation. That's could actually end up being your biggest variable in your whole trial. So just because of the fact of it's a very complex unit, trying to get a small amount of product all the way from your tank to each individual opener. The wider your drill, the more variability you're going to get. Just right off the bat, we'll show you that example. We took, for example, a 70-foot wide air drill, say a 4-rank machine. It would be about 10.5 feet long. That you can barely see it anymore, but it's a white paint out right there. That's the footprint that air drill would have. At 5 pound per acre seed rate of canola, that's the total amount of canola seed that needs to be accurately placed into that large area of the drill, just to cover that small area. Now you're gonna go a mile down your field and try to accurate meter that as you're going. It's not a lot of product, and to try to get it accurately metered. And this is a high volume of this 300 pounds per acre fertilizer rate of actual N. So that's the total amount of product that would be going out into that area of your drill. Just that 70 by 10.5 foot footprint. So there's a lot of things that can happen right off the bat. So
we ran these samples through this system. If you imagine these 6 openers being spaced at 12 inches, that would be, these sample bags would be distributed over 116 feet. And I'll pass around these bags. These two, this was the most variation of any of the samples we run, and it was almost 7.5%.
So then your first thing you're going to need to do is get your drill leveled out. It's more critical in the older flexible style frames versus the newer drills with the independent link openers. But you still got to get your depth set on each opener in that situation. But you can have anywhere for up to 2-inch variability of depth if you don't have your frame level from one side of your drill to the other. Just something you need. Like we find that all the time. Just if the drill isn't level. Then your next one is when you know the product you're going to seed, you got to calibrate. Calibration, it's just a guideline, and most calibrations are done stationary, so that will significantly change when you go from that stationary calibration to an actual seeding. There's so many things that change your meter rate, product density, product flow, the slope of the field, vibration in the machine, airflow. If the right meter for the right product, that's pretty critical. Those type of moisture condition, humidity, I guess I should say. So all that stuff will affect your metering. So just be aware and keep. You got to closely monitor the amount of product you're putting out as you're going. There's no other way unless you're going to take the amount of product that you if you're going to calibrate by running your drill a certain distance and collecting that total amount of product, it's the only way you're going to get a fairly accurate calibration, and you're going to have to do that for quite a distance to have an accurate calibration. So it's not practical, but that's what we do in the research side of things. We have to do that, and so that's why we know it can be very significant. Then the next thing is you go to your seed. You got to have your depth setting. That's pretty critical. Joe's going to pass around these pamphlets here, and gives you a good idea how much variability you can have with your seed depth. Different openers, different soil type. All openers work. in the right condition, but they don't. Not one opener works in all conditions. So your drill is unique to your operation. The manufacturer or the whoever built and designed it, and then they went and tested it in whatever condition that they found, maybe in 2 or 3 different situations. Well, now once that drill comes to your field, your operation, it is unique. It most likely was never tested in any situation comparable to your operation. So you know your drill better than the manufacturer. That's all I can say. They can tell you all they want, but it's different from what they know that drill from. So just be aware that the depth now, and so the opener has a huge effect on the depth placement just in itself, just based on the level of the soil disturbance it creates, the way it puts the seed down, whether it's a narrow band or a spread tip or whatever, and then whether it's double shoot or single shoot, how it separates your product. Some put fertilizer above the seed, some below, some with the seed. The opener is also unique to your operation. But anyways, depth variability is just huge. When we do a research plot, we do it on small scale, so we take out the variability that you encounter in a field. So the area is small, the plots are small. They're typically 50 feet by 10 feet wide. We do all this setting, the calibration, the drill level, the depth setting. We focus a lot of time on that. Then we go in and seed our treatments. Immediately after, we go in and we'll take up to 16 measurements at depth placement in one plot. That's where these numbers are coming from. We're getting anywhere, depending on the opener type, but anywhere from plus or minus a 1/4 inch depth variability in just that small of area, up to you can have a 1 inch plus or minus depth variability just in 50 feet. So imagine a 70-foot wide drill going 1 mile down the field, and you're trying to do a research trial comparing 2 seed types, and it gets pretty hard. You gotta watch what you're actually looking at when you go in and you start taking your emergence and your yield measurements. The variability could have just simply been the seeder itself, not the seed types. So once you go into that, now the next big variability is just distributing that seed from the meter to the opener itself. That's what we got displayed here. Your style of distribution manifold, the number of ports on your manifold, the amount of times it's being separated with manifolds, the length of your hoses, the amount of time, directional changes of your product type going from the meter out to your opener, your airflow, your product density, product type, the slope of the field as you're running. Everything changes how that seed is being evenly and accurately distributed through the system. I don't know if we need to run this right now. Okay, we can run it one more time. We'll just do a quick example. This sample is the amount of product.
No, it's a random amount.
Oh, this is a random amount, okay. We'll run it. Yeah, we'll just run it and we'll explain it.
Maybe.
picking on any style or anybody's particular type of manifold here. This is a pretty standard actually style of manifold, vertical dam. There's the flat fan styles and whatnot, but you can probably clearly see some difference now in the amount of product being distributed out. That's fairly typical. We find anywhere from 3 to 6% variability, and that's pretty well standard with all vertical dam type manifolds. Well, actually all distribution manifolds, period. That now, as soon as you add the slope into this, or if the manifold isn't level, it increases your, like 3 to 6% is when that manifold is just right. That's including the imperfections in manufacturing and with it at a level. So now, like I said, if there's an imperfection inside of it, or it's not quite level on your drill, it'll significantly impact the distribution of that machine. And as you can see, the one canister is after 2 runs now, it's almost half the amount of product as the rest of them. Well, we simulated a problem there. We plugged off a portion of that hose there, so it has a little bit of less airflow. Something you typically will see is, well, product and air rule is it will take the path of least resistance. So generally a long hose has more back pressure, so it'll tend to have a little less product. Yeah, it looks like it is starting to show that itself too. So
that becomes more pronounced when you don't have blockages or partial blockages in any other lines. That's why it may not be quite as much of a difference as it normally would be.
So to put in perspective, if you have a plugged opener, that's the same thing. That will significantly impact your distribution uniformity in your manifold, and it doesn't just impact all or one other hose. It changes the variability and the distribution in all of the rest of the hoses of that port. So now, like I said, now if you're going from a 40-foot wide unit to now a 70 or 80 foot, all of your distribution lines are longer. It takes more air to get that product accurately pushed out to the end. And then separate, and then to separate again in the manifolds, and then out to the openers. It just compounds. The wider you get, the more problem there's going to be.
We also ran this system. We tilted it with this far side up. Those 3 tended to be the heavier samples that we got. However, when we tilted the thing by 10 degrees, because the heavy side was on top when it was on the level, those 3 samples ended up being a little lighter, so the variation with the tilted run versus the level run was less. So it doesn't necessarily, the slope may not necessarily impact negatively, but it does change it.
And probably the biggest problem that this is causing is your plant population, I guess, is what it would be. What you're going to see in the field, or if it's fertilizer, you're going to see streaking from more fertilizer in one wing versus another. That's the type of things you're going to see. Depth placement, you're going to just see reduced or increased emergence. It depends on how good the depth was. But that could be your biggest variable right there, is your seed depth placement. Ground speed is huge. If you're going to do an on-farm trial, you have to slow down. Some openers can do quite well at 6 miles an hour, but there's very few of those openers out there. Generally, we do all our test trials at 3 or 4 miles per hour. Slower would even be better, but you got to be a little bit practical too. So as soon as you go up to 5 or 6 miles an hour, we often see huge seed placement variability, and then that affects your emergence, as you can see in some of the back charts in those pamphlets that went around.
that same variable, like some carts have a single hose that goes to split and then to all the manifolds. Other ones split it right at the cart straight to these manifolds.
Yeah.
You see that same variability where it comes from one hose that then splits to all these manifolds?
No, basically you're just compounding it. Every time you have to split with a manifold, you're adding another 3 to 6% variability. Yeah. Yeah, every time.
What about RPM on the fan? Would that change? I mean, I don't know what your little fan did there.
Yeah.
Does it change when you go from 2,800 RPM on that fan to 4,800?
Yeah, absolutely. Fan speed makes quite a difference, because again, especially the amount of times that the seat has to change direction. If you got sharp directional changes like 90 degrees here, the seat's going to take the least resistance. Higher fan speed it's going to ride the outer side of that hose, and then it's going to be even harder for the manifold to distribute that more accurately.
So the variability, especially over a 70-foot run, because a lot of guys say, well, you know, I've got a lot of fertilizer, say on peas, they're putting higher rates of peas on or whatever it might be. As they go up in volume, they think, well, I got to increase my RPM because I don't want to plug. I want to push lots of air.
Yeah.
But if the higher you go in air, increases your variability, you got to stop and think, what am I doing, right?
Yeah.
And again, they want to go fast, right? So
Yeah.
instead, I'm not going 3.8 or 4.1.
Yeah.
I'm going 5.8 or maybe I'll be 6.3. So then they really got to push air. The higher they push air, the more variability they get. Right?
Yeah, that's right. Yeah, the best you can do is try to operate with the lowest fan speed possible. That's taken into account not pushing the product to your openers on level ground, but considering if your tractor's going up a hill and you're having a power drop, you have to consider that when you're setting your fan speed.
One of the typical rules of thumb is if you pull your hose off from the furthest point away from your meter, hold that one up and get someone to crank the meter a couple times, and you want your product to come about a foot over the end of the hose. And that's basically your minimum fan speed that you want to run at before you start encountering things with plugging. I suppose that also depends on the speed. That could change a lot if you're going 3 miles an hour or 6 miles an hour. So you would have to take that into account as well.
Yeah, I think that's all. I guess one thing, just to mention how critical all these things that I mentioned we set for the drill. So, just for a funny little story, but most of the research we do, so we go in, and then at the end of the season we measure the yield on all the plots. We're probably measuring something more like fertilizer rate or something, and placement. But we average all of those numbers together from all of the plots, so that's taken out the variable, and then you average that yield together, and then the field surrounding that is seeded just conventionally. None of the pre-settings were done. Nothing done particularly precise. We've seen often up to 40 bushels per acre higher yield within the plots, and so that's likely not because of fertilizer in the plots would have had some checks where there's no fertilizer, but the yield is still that much more. It's likely because the seed placement and the setting of the drill on the outer part of the field just wasn't operating the best for all of the conditions that was encountered during that seeding operation. Just something we see quite often. So now Joel's going to talk about some harvesting stuff.
So who knows what this is? Pardon? Close.
Oh, it is.
So that's what this is. This one in particular is your mass flow sensor. which correlates more directly to your yield. This is the moisture monitor, or the moisture sensor. Who are the guys that run combines trust your yield monitors? Why not?
Oh,
You don't calibrate.
human errors. Yeah.
Some of the numbers that I've found doing a little bit of research on this, if you were to buy a new combine or retrofit a combine with an off-the-shelf yield monitor, your yield monitor could be off 100% or more. So you're right, if you don't calibrate it, like Ken said, it's bad data. What's the point of having it then? If you calibrate it at the beginning of the season, and you go and combine your 4,000 acres or your 5,000 acres, by the end of your season you could be off 10% or more. However, these can be a very valuable tool if you are on top of calibrating when moisture changes, when you're in different geographic locations, different varieties, different crops. You can be easily within 1 to 3%. So there's no reason that you can't say I can trust this. And if you're doing your on-farm research, we make the assumption that you want good data. Because if you don't have good data, if this is off 10% and you've got a 100 bushel wheat crop, do you know if your different treatments, if you're doing strip trials, one says 100 bushels and one says 110, do you have any confidence that the 110 is actually 10 bushels better than the 100? Because what's 10% of 100? So then you could be within plus or minus 10. So you have no confidence of your data if you're within 90 to 110. However, if you're within a percent or two and you see a 10 bushel difference, you have a lot of confidence that treatment A versus treatment B, there was a significant difference.
But if both treatments in the same field are 10% off, aren't they relative to each other?
I'm not exactly sure how accurate these are in terms of, if you look at accurate, it's a good visual would be how close you are to the bullseye of a target if you're throwing darts or with a bow and arrow. Whereas precision is more, if you've got one way off to the corner, are they all clustered around that one? So I'm not sure the precision and the accuracy, what the differences are with the machine. But 10%, you're within 90 to 110. You're not sure if that's an accuracy or a precision type of error. So who knows how to calibrate the yield monitor? What do you do?
Set it to calibrate, combine something, go weigh it, set it, tell it what it weighs. In a John Deere.
How many times should you do that?
3 times.
One Rocky
I don't
Mountain.
Yeah.
Going to visit all the dealers. They all said very similar things. If you don't calibrate it, what's the point? That's the biggest thing. Most of the manufacturers will suggest you run 4 to 6 calibration loads, running at different flow rates, so you're cutting a quarter or half or 3/4 or a full swath. And that gives you a better calibration curve instead of a straight line. It gives you more of a curve so that your computer knows that, it can understand what the electrical signal coming out of that sensor is actually representing. So the more calibration loads you do, the better off you will be in terms of being confident in your data. Yeah. Do you guys use weigh wagons or scales? When you calibrate? Drive out to the scale?
You're asking a long question. How many guys calibrate?
Well, there is some options. If you don't want to buy a weigh wagon, you can outfit your truck with either load cells or you can tap into the air system and you'll be able to get all that data in the field a lot easier than if you drive out to a scale. Makes a big difference. Calibrating your moisture sensor and your temperature sensor is also very important. Who knows how to calibrate the moisture sensor? They're going to tell you to clear all the data out of your computer You run until your average moisture stops major fluctuations. At that point, you can go in and you take a number of samples through your hopper and you take it out to someone who has a moisture meter that you trust. That's the key. Some of the key things that we want to point out to you, if you've got a yield monitor on your combine and it's set and you know that it's within 1%, it's still not going to tell you what the limiting factor for yield is. All it will tell you is the response to the limiting factor. So if your trial design is good and you are confident that the differences in treatment contributed to that difference in the yield, that's a lot more important, and that's going to come a lot from clear documentation. Make sure you write everything down.